All right, if we are expanding the following conjugate binomials to detect a pattern, then for the first case, if I have x minus 5 times x plus 5, well, the x times the x is going to give me x squared. X times 5 is going to give me plus 5x. Negative 5 times x is going to give me minus 5x. And the negative 5 times the positive 5 is going to give me negative 25. The positive 5x and negative 5x will cancel out, and I'm just going to get x squared minus 25. In the second case, if I have 2x times 2x, I have 4x squared. 2x times negative 1 is going to give me negative 2x. 1 times 2x is going to give me positive 2x. And 1 times negative 1 is going to give me negative 1. Middle terms are going to cancel each other out, and I get 4x squared minus 1. Binomials which have the same terms but opposite signs are called conjugates. So we can see here that we have the positive 5 and negative 5. Here we have the positive 1 and negative 1. But when you don't look at the signs, the values of all the terms are the same. So we could say that if I have a minus b and a plus b, it's always going to wind up being a squared minus b squared. We learned the opposite of this when we were looking at how to factor difference of squares in grade 10. So if I'm going to expand and simplify, if I have radicals in here, well, I know that the middle terms are going to cancel out. So if I think of foiling, then this part and this part aren't going to matter because they're going to be the exact same, just opposites, and cancel each other out. So all I'm going to do is I'm going to square the first terms and get 2 times 2 is 4, and the square root of 9, which would be the same as 4 times 3, or 12. And the 1 times negative 1 is going to wind up giving me negative 1. If I have 12 minus 1, I just have 11. Now, as we've already seen, anytime that we're doing this, if I multiply a radical by itself, it's just going to get rid of the radical. The square root of 5 times the square root of 5 is the square root of 5 squared. That's just going to give me 5, which means negative square root of 2, positive square root of 2 is just going to give me negative 2. And I can simplify that to a 3. If I'm identifying the values of the variables for which each expression is defined and then expand and simplify, state the restriction on the variable, well, in order to take the square root of it, a just has to be greater than or equal to 0, because I can't take the square root of a negative. And then I'm going to use exactly what we did in the last part and say, well, if I have the square root of a times the square root of a, it's just going to be a. The two parts are going to cancel out. So I can say that I have 3 times 4 is going to be 12, and a. When I multiply the 3 root a and the 5, I'm going to multiply the coefficients, and I'm going to say that it's going to be positive 15 root a. Negative 2 times 4 root a is negative 8 root a. And negative 2 times 5 is going to be minus 10. Then I can only combine the middle terms. I have 12a plus 7 root a minus 10. If I look at example B, then I'm going to do the same process. Just make sure that you're squaring this out properly. If I want to square that out, then I know that it's going to be the same as if I'm multiplying by itself. Don't just square the first term and square the second term. So the first one, I'm going to FOIL out this multiplication, and I'm going to get root x is x, root x and 2 root y is going to be to root xy. Negative 2 root y times root x is going to be negative 2 root xy. And negative 2 root y and positive 2 root y is going to give me negative 4y. These parts are going to cancel out because if I take a look, they're just conjugates. For the second part, I'm going to say that I'm actually just squaring the terms out, which means that if I have 3 times 3, it's going to give me 9. Root x times root x is going to give me x. The middle term is going to come from 3 root x plus root y times 2, or 6 root x y. I could have done the 3 root xy here and 3 root xy here. It's still going to take me to the same place. And root y times root y is going to give me plus y. Now I'm just going to combine my like terms. I have my x here and my x here. I have my y here and I have my y here. And then this one does not have, excuse me, this one does not have a like term. So I have ten x's. I have negative 4 y's and plus 1 y, negative 3 y's. And then I have plus 6 root x y. If we're looking at dividing, the rules for dividing are pretty much the same as they are for multiplying. I'm going to divide the coefficients, and I'm going to divide the radicands as long as they have the same index. So, for example 5, first thing I'm going to do is 8 divided by 2 is going to give me 4. 16 divided by 8 is going to give me 2. And I can't simplify that. There's my answer. In the second case, if I had 4 divided by 12, I can simplify that to 1 over 3. If I have 6 divided by 3, then I can simplify that to the cube root of 2. Or I can just call it cube root of 2 over 3. For the last one, I'm going to multiply, and then I'm going to divide it out. So first thing, I'm going to multiply the 4 and the 2, and I'm going to get 8, the 2 and the 6, and I'm going to get the square root of 12 over 12 root 3. 8 over 12 is going to simplify to 2 over 3. And 12 divided by 3 is going to be the square root of 4, which would be the same as 2 times 2 over 3, or 4 over 3. If I'm doing a process called rationalizing a denominator, in order to fully simplify a quotient which contains radicals, you have to rationalize the denominator, which means that you can not have a radical in the denominator. Use the idea that multiplying an expression by 1 does not change its value. So, if I am trying to simplify this, the first thing I'm going to say is, well, I need to multiply the top and the bottom by something that will get rid of the denominator, or not get rid of it, but get rid of the radical in the denominator. So I'm going to multiply the top and the bottom by the square root of 3. Because root 3 over the root 3 would be the same as 1. Now, when I multiply a radical by that same radical, then if it's square root, it's just going to eliminate the radical sign. Root 3 times root 3 is going to be root 9. Root 9 is just going to be 3. So I can say right from the get-go that this is going to be 6. Well, I got to do the 8 times 3 is going to be root 24 over 3. Now, there's two things I can do. One is I can divide the 6 by 3 and get 2, and I can simplify that square root of 24, and that's going to be the same as 2 root 6. Or 4 root 6 is my final answer. For B, I only need to multiply the radical part to get rid of the radical. I'm just going to multiply the top and the bottom by the square root of 5. So, on the top, if I have 4 root 5 times root 5, it's going to eliminate the radical. I'm just going to have 4, and where I eliminate the radical, I'm going to put in brackets to remind myself to multiply the 4 and the 5 again. And then minus 3 root 5. On the bottom, 2 root 5 times root 5 is just going to give me 2, and then I'm going to eliminate the radical and get a 5. This is going to be the same as 20 minus 3 root 5 over 10. And this I can't actually simplify further because if we think back to our quadratics, I would need to have a common term in, or a common factor in all three parts here. Alright, and the last one. I'm going to simplify this first just to make my life easier. And I'm going to say that this is going to be the same as 9 root 2 minus 3 root 5 over square root of 12 I can actually write as 2 root 3. I'm just doing this so that I only have to multiply by a smaller number. So now I can multiply the top and the bottom by root 3. And on the top, I'm going to get 9 root 6 minus 3 root 15. And on the bottom, I get 2 times 3. And I can see that all three parts, even before I multiply out the bottom, I can multiply it out if I want, if it makes it easier for you. 9 root 6 minus 3 root 15 over 6. I have a common factor of 3. So I'm going to divide all three parts by 3 to simplify it. And I'm going to say that I have 3 root 6 minus root 15 over 2. And there's my final answer. All right. And the very last part, simplify and state the restriction of the variable x. Well, because it's saying that it's a fourth root, anytime I have an even index, that means that x has to be greater than or equal to 0. Then what I'm going to do is, because it's a fourth root, in order to cancel it out, I need to do this to the power of 4 and this to the power of 4, or all of it to the power of 4, which means that I need to multiply the fourth root of 3x in 3 more times. So I'm going to say that I'm going to multiply on the top. Fourth root of 3x times fourth root of 3x times fourth root of 3x. Do the same thing on the bottom. And that's going to cancel out the radical on the bottom. On the top, I'm going to have 4, and the fourth root of 3 is going to be 27, x to the power of 3. And on the bottom, I'm going to have 15x.